So we'll go ahead and put 4. 4 really goes with all of these. But so for the things that are happening, just in case you missed it, is that when you add and subtract things, the range and the standard deviation don't change, because all you do is you take the same amount and you just kind of shift it. But the median used to be here and now it's here, and the mean used to be here and now it's here. So the mean and the median both change when you add and subtract. And these are our central tendencies. Now, when you multiply, everything changes. And essentially, everything gets multiplied by whatever that number happens to be. So, let's go ahead and check out what we've got going on here. So, we are going to revisit our 27.1, so I need to find that. 27.1. Here we go. So here is our baby weight question. And it says that in 30 years from now, the average baby weight is projected to be, instead of 7.6, it will be 8.7. So we're going to go up 1.1. And then it says, how will the standard deviation be affected? So if all of the guys just gets multiplied by 1.1, I'm sorry, not multiplied by added, then the standard deviation should not be affected. Now, we are assuming that the average indicates that all of them did stay exactly the same. So let's look at the next one. So now we have that humans' weight is 1/3 of that on Earth. So we would divide our amount of the original 7.6, because we are talking about now, divide it by 3, and that would be 2.53. Now, it doesn't mean that the mass is different, it just means that the weight is different because we have different gravity here. How will the standard deviation be affected? Now that is that it's going to be 1/3 of the 1.3, 1/3 of what it was on Earth, which would be 1.3 divided by 3 is 0.43 for our standard deviation. So again, anytime you multiply, it affects everything, but if you add or subtract, it just affects the central tendencies.